Please don't forget to like, subscribe, and comment. Thank you so much.
Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +2348085095144 to learn more and get started today.
An irrational number is any number that cannot be expressed as a fraction. I told you. An irrational number is any number that cannot. You can't express it as a fraction. It cannot be expressed as a fraction. Anything you can express as a fraction is a rational number. I'll just give you a few examples. For instance, what's 0.2? What's 0.2 in fraction? Did you hear me? 0.2 in fraction is 2 over 10 now, is it not? So 0.2 is a rational number. Also, 5 in fraction is 5 over 1. So 5 is a rational number. All these ones are rational. They are all rational because we can express them in fractions. So these ones are rational numbers. But the ones we cannot express as fractions are irrational numbers. Something like pi, square root of 2, square root of 3. These ones are irrational numbers. You can express this one as a fraction. And decimals that, pi itself is 3.142 dot 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 dot. It continues. Do you know? Pi is not actually 3 over 7, 22 over 7. It's just an approximation. The pi itself is 3.142, yes, and it keeps repeating. Yeah, so it's irrational. There's no way you can express this as a fraction. Now, all these ones, root 2, root 3, the ones that don't have a perfect square are surds. That's what we did on that surd. Now, are you still there? Are you still there?
Yes, I'm here.
I want to give you another example of something. Then you tell me whether it is rational or irrational. If I have 0.55 or 0.555, it keeps going. Is this one rational or irrational?
0.55555.
Yes.
Is it an irrational number?
It's actually rational because we can express it as a fraction. That's what I want to show you now. 0.555 is rational. I will explain something to you about that. It's recurring, or 0.62.
Wow. How would you express it?
That's why you are learning now, and it's interesting. I will just show you very briefly. 0.6262626262, or maybe you might have 1.545454, or even 1.514141414. You can have 1.5141414. This is rational because it can be expressed as a fraction. Anything you can express as a fraction is rational, and I will show you. Are you still there?
Yes, I'm here.
Okay, so you asked a good question. This is the step, and I'm going to illustrate it with an example. The steps, let's go through the steps first. Identify the repeating digits in the given decimal number. Equate the decimal number with x or any other variable. I'm going to use an example to illustrate this. Let's use, like this one I wrote, 0.555555555. Did you see that? The repeating digit is the first digit. It's the first digit that is repeating. So you identify it first. Look at the steps. It says identify the repeating digit. Identify the repeating digit in the given decimal number. The repeating digit is the first digit. That's the one that is repeating. So we have identified the first digit. The second question, equate the decimal number with x or any other variable. So I'm using this as an example. Example, let me write it down. Example, we will continue with this. Example is express 0.555 as a fraction. So we have identified the repeating digit. The digit that is repeating is the first digit. The first digit keeps repeating. You know, this one is the first two digits that keep repeating. 62626262. You understand? This one is something else. I will show you. It's like the first three digits. The first 1 2 3 4 third and fourth digits that keep repeating. Okay, so the first digit is repeating. So we express that as we write it, equate it to a decimal x. So this is how we just start. I will say x equal to 0.555 if you like. Did you see what I wrote?
Yes, I can see it.
Okay, let me show you the next step. The next step is I've done step one. I've done step one, identify the repeating digits. Like in this case, it is the first digit. I've done the second step, which is equate that decimal number with x or any other variable. The decimal number. Okay, so I've done that. X is equal to 0.55. Okay, the third one is place the repeating digits to the left of the decimal number point by multiplying the equation obtained in step 2 by 10, or power of 10 equal to the number of the repeating digits. Let me explain to you. Let me explain to you what that means. Are you still there?
Yes, I'm here.
Let me.
So your voice is breaking.
Okay, I think your internet was going low, but it should be stable now. Let me just say that and then show you what to do. Okay, what we do is, since it is the first digit that is repeating here, we multiply it by 10. But this one that it is the first two digits that are repeating, we multiply it by 100. If it is the first three digits that are repeating, we multiply it by 1000. Like this one. If we had 0.835, 835, 835, we would have multiplied this one by 1000 because the first three digits are repeating. I would have multiplied this thing by 1000. But this one is the first two digits. I'll multiply by 100. That's 10 raised to the power 2. This one I'll multiply by 1000, which is 10 raised to the power 3. This one, since it's the first digit, I'll multiply by only 10, which is 10 raised to the power 1. Does it make sense? You still can't hear me again? The first digit is repeating, so I multiply by power of 10, you know, power 1 to the 10 to the power of 1. If it is the first two digits, I'll multiply 10 to the power of 2, which is 100. If the first three digits, I'll multiply by 10 to the power of 3, which is 1000. So I multiply by 10, I'm going to have, so I will write multiply by 10, or 10 to the power of 1. Okay, so I will just tell you, first digit is repeating. Can you hear me now? Confirm if you can hear me. I can see what I'm writing. Can you hear me now?
Yes, I can hear you.
Okay, so
But I have a question.
yes, please do.
Yes, I can hear you.
Ask your question.
So how about the one? What about 1.514?
I like that. I like that. That's a very interesting question. We come to this one. You asked a very beautiful one. This one is this one is there's a different method we're going to apply to solve this one. So I will come back to it. Did you hear that? I will come back to this one. It's slightly different. There's a trick we will use in this one. What I just explained can only go for this, and for this. But when we come to this one, we have to apply a different trick. I will show you. Did you hear me? Remember this one, the first digit is repeating, so we multiply by 10. This one, the first two digits are repeating, we multiply by 100. This one, the first three digits are repeating, so we multiply by 1000. But when we come to this one, it is different. I will show you what we do. Okay, so did you get my explanation? Is your internet still breaking?
Yes, I did.
You got the explanation, okay.
Yes, it's
Yeah, okay. So first digit is repeating, we multiply by 10 for this one. First two digits are repeating, we multiply by 100 for this one. First three digits are repeating, we multiply by 1000 here. But this one in green is different. I will explain it to you. There's a trick we use. First, in fact, we first of all multiply by 10 before we do all that. I can just tell you. Okay, let me just say it so that when we are solving it, it can be easier. First of all, you have to multiply this one by 10. First of all, multiply it by 10, and then you multiply it by something else. Okay, let's just finish this one. Multiply by 10, so you're going to have 10x is equal to, multiply this other one by 10, you have 5.55. I would have called this one equation 1. So this is equation 1, and this is equation 2. Subtract equation 1 from equation 2. So you just do equation 2 minus equation 1. What do you have? Give it to me very quickly. Let's finish it up. 10x minus x will give you 9x. 5.55 minus 0.555 will give you what? 5. So x is what now? 5/9. Put 5/9 in your calculator.
I can't hear you anymore.
Oh, sorry, your internet dropped so much in quality. I said after you have multiplied by 10, you know we're multiplying by 10 because it's only the first digit that is repeating. You obtain equation 2. The first one is equation 1.
I've multiplied by
Sorry, let me hear you again. Wow.
after
Yes, say that. Go ahead.
I've multiplied.
Wow, your internet is really dodgy today. But have you seen what I've written?
Yes, I can see it.
So after we multiply by 10, you know, multiply each thing by 10. This times 10 gives 10x. This times 10 gives 5.55. And then you subtract. You do equation 2 minus equation 1. As is shown, you do equation 2 minus equation 1. 10x minus x will give you 9x. 5.55 minus 0.55 will give you 5. You know, of
That is 9x.
so 9
And then 5.555.
minus this will give you approximately 5. So make x just solve the equation. X is equal to 5/9. I need you to even try it. Put 5/9 in your calculator to check.
Yes, I've seen it.
Did 5/9 give you that?
That's
Okay.
fine.
If you check,
Yes, 5/9 is
so
0.5555.
all right. So like I said, when you are doing this one, in yellow, what will you multiply by? When you are doing this one in yellow, what will you multiply by? You multiply by 100 because the first two digits are repeating. When you are doing this one in blue, you multiply by 1000. When you are coming to this one, we do it in a slightly different way, which I will explain to you. Okay. For this particular question, you know, like you're asked to convert 2.7646464 to a fraction, you know, 2.7646464 to a fraction. It's not the same as the other ones we did, like this one. As it's not the same as 0.222. It's also still different from 0.999 or even 0.787878. By the way, for 0.222, just a quick reminder, what will you multiply by? Do you remember what I'm talking about?
I'll multiply by 10.
By 10, because
Yeah.
the repeating digit is the first digit. For 0.9, that's correct. You multiply this one by 10, and then you'll be able to get it, just like we did for this question on the right hand side. This one, the first digit is the repeating fraction, so we just multiply by 10x. By 10, we made x equal to this, multiply by 10. So 10x is equal to this one times 10, 2. 10 times x, 10x, 10 times this one, 5.55. And then we're able to solve for x, because the first digit is the repeating or recurring decimal. But if it is this, if the first two digits are the recurring, like this one, what will you multiply by? Like 0.787878, what will you multiply by? You can see it is the first two digits that's a recurring decimal. First two digits. So what will you multiply by? Can I hear you? Yeah, what can you multiply this one by?
By 100.
We multiply this one by 100. Okay, because the first two digits is recurring decimal. Alright, what about 0.999? What will you multiply by?
I'll multiply it by 10.
By 10, because the first digit is the recurring decimal. Alright, now when we come to something like this, 2.7646464, you know, the digit that is the recurring decimal is actually this. But so we need to do something tricky. We need to move the decimal forward. Multiply it by something that will move the decimal forward first, so that we can now get to the recurring decimal. That's why I multiplied by 10. We first multiply by 10. So remember, x is equal to 2.7646464 and so on, recurring, so that we can move the decimal forward to the first digit. Are you still there?
Yes, I'm here.
Oh, okay. Sorry, I thought you were the one that needed, this attention was needed. So we multiply by 10 to move it to the first, to this, move the decimal point forward.
That's why I didn't want to.
Can I hear you better? Can I hear you better?
No, yes, I can hear you.
Okay. So we have done that. The next thing is, we multiply this by 10, and we have 10x, and we multiply this one by 10, we have 26.64646464 recurring. What do you think will be the next thing we should do? Are you still there?
Yes, I'm here.
Now, then what we will do is to multiply it by something that will make us move this whole thing in front of the first, the place that the recurring thing stopped. You will understand what I mean. Where did the first recurring thing stop? Tell me where the first recurring decimal stopped. Where did the first recurring decimal stop? In front of what? That's after what? After what digit? I need your response, please.
After the first digit.
No, hear me out again. I said, wait, what number did the first recurring decimal stop? The first recurring decimal stopped at what digit?
4.
It stopped at 4. It stopped at 4. The first recurring decimal stopped at 4. So what we're going to do is to multiply it by something that will take it to in front of the first recurring decimal. What will you multiply this thing so that it will take it in front of the first recurring decimal?
You multiply by 1000.
Okay, so we're going to multiply by 1000. So let's multiply by 1000. I'm going to take another example to help you appreciate this. We multiply by 1000, so 1000x is what we're going to have. This will be 1000x. Remember, what we're multiplying by 1000 is this first thing. So multiply this by 1000, you're going to have 2764.6464 recurring. Did you see that? Call the first equation. This is the one you will now call equation 1, and call this one equation 2.
Yes, I did.
Yeah, these are the two we now call equations 1 and 2. This, we had to apply some tricks. This is the one we now call equation 1, the yellow one, and we call the blue one equation 2, and solve equations 1 and 2. Subtract equation 1 from equation 2. So equation 2 minus equation 1. What does it give? Go ahead and do this. Equation 2 minus equation 1. Are you working it out?
2737.
I'm talking about this one.
Yes.
The first.
2700.
Have you done?
You get
100x minus 10x first.
Yes, I have
100x minus
990x.
So 990x
Yes.
is equal to
990x
is equal to
is equal
this minus this. This minus this. Okay, it's equal to what?
is equal to 2737.
37. So x will now be what? 2737 over 990. Check that with your calculator to prove that. Proof. Or check if it will give that.
It gives 2.764.
No, I mean 2737 over 990. Yeah, it gives the same thing. 2.76464, is it not?
Yes.
2.76464 recurring and so on. Okay, I have to take one more question so that you can appreciate this better. Go to the next page. Let me just treat one more before you do this work. Are you there? Go to the next question.
Okay.
Before we look at the tricks. Convert. Just a moment. convert 3.15343434 recurring to fraction. What do we do?
Okay.
Okay.
So first, you turn it into an equation.
Okay, so this becomes x equal to
It becomes n
3
equals to
3.1534
3.1534.
3434 recurring. What next?
No, then after you multiply the equation by 10, I mean by 100.
Okay, why are you multiplying by 100? To move this in front of the first recurring, isn't it?
No,
Yes, I'm here. Why are you multiplying by 100? Tell me why you're multiplying by 100.
yes, it becomes 100.
Okay, let me write what you just said. Multiply by 100.
Yes,
So why you multiply by 100? Can you?
to
Yes. Why we multiply by 100 instead of 10?
remove the two non
To, okay, to move it in front of the two
to remove
non-recurring.
to remove the two non-recurring decimals
All right, so that's correct. Multiply by 100, we have
because
100x.
one
Yeah,
and five.
you're right. 100x is equal to
Yes.
315.343434. Okay, you know what I would do? Okay, all right. Let's leave it like that. Let's leave the question like that. Okay, what next? What's the next thing?
So then you multiply it by another 100.
Not another 100 though. Okay, see, we are trying now to move it to the very front of the first
You
recurring.
multiply it by another 100.
No, no, you see, it's not by another 100. Watch me. We are trying to move it to the very to the
Oh, yeah,
that's
you're
after.
multiplying it by 1,000.
Is it 1000?
1,000.
Is it 1000 because we're moving it to the front of that's after the last recurring
No, 10,000.
by 10,000
10,000.
because we want to move it so that it will be after the first recurring. After the first recurring, we want to move it to come to the point where it will be after the first recurring. After the first recurring is 34, so it needs to come to this. So we multiply by 10,000. That's 4 zeros. So let's multiply by 10,000. Remember, what we're multiplying by 10,000 is this first equation. So multiply by 10,000.
That will make
That's this by 10,000 and also this by 10,000.
that will make it 10,000 x equals
10,000 x
31534.
31534.3434 recurring. Okay, so what do you do now? You can call this first one, this one equation 1 and this one equation 2. What do you do now? You now do equation 2 minus equation 1, is it not?
So then you do equation 2 minus equation 1. Yes.
So this minus this gives what?
Which will give 9,900 x equals to
9900x
equals to equals to 3,100 and 31,290.
31,200 what?
19.
219. 31,219. Okay. Finally, we solve for x. X will now be what?
So we divide this by
9,900. Okay.
9,900,
Let's do a check. Check if that gives that.
and then that's
Check. Can you check? Do a check.
yes, yes, that's it. That's the answer.
Okay. 3.1434. 3.143434 recurring. Okay, so that's a quick step. So in summary, when you have a situation like this, you first of all multiply it by a power of 10. That's something that has a number of zeros, so that it can move the decimal point to where the recurring decimal starts. Where recurring decimal starts. Okay, so let me just put it in bracket to move it to where the recurring decimal starts. To move decimal point to where recurring decimal starts. Are you getting what my additional information?
Yeah.
That is to move to, so that we can move it to where the recurring decimal starts, and recurring decimal starts after 5, so we need to multiply it by 100. After you've done that, you multiply this by 100, 100x, multiply this by 100, you get this. Call that equation 1. This is a special case for this type. Then you need to now multiply it by something that we move it in after the first recurring decimal. After the first recurring, or the full recurring decimal after the first of it. So after the first is 34. So we're going to move it to here. That means you need to multiply by 10,000. Okay, so let me write it. To move decimal points after the first recurring numbers. Or recurring number starts. Alright, I think that makes a good summary. Okay, so in this case 10,000, and you form equation 2. You just subtract equation 2 by equation 1 to get that. Now I need to tell you a quick trick you can use for the simpler one. Just look at what I wrote here for the quick trick. So that's an easy trick you can use for these ones, like 0.444. You don't need to go through that process. Just write since the recurring decimal starts from the first digits, it will be 4/9. For this one, the recurring decimal is the first 2 digits. It will be 78/99. If it is for the second 2 digits, it will be. That's the trick we use. Did you see that?
Oh, that is a good trick.
That's a good trick. Let me give you this one. 535 535 0.0535 5 no no let me write it properly. 0.0534 534 534 recurring. What will it be?
It will be. It will be. It will be 534 over 999.
534 over 999. That's correct, because there are 3 recurring decimals, 534, so it just be 999. So this one is, the first digit is the one recurring, that's why it's over 9. This one is 2 digits that are recurring, it will be over 99. 3 digits that are recurring, if you like, you see this one, you could have written it like this. So you see this 0.999, assuming I call it 0.999999, you might want to take each of these 3 digits as a recurring, like this first recurring, this second recurring. You get my point? So we might want to make it we can call it 999 over 999. We get the same answer. I don't know if you got the logic. Did you get my explanation?
Yes, I get it.
Because if it is 0.9999999, if you take the first 3,
Yes.
it becomes 999 over 999, which is 1. If you take the first 2, I could have used the first 2, I could have said 99 over 99, or the first one 9 over 9, you know, whichever method you use. I can think of it is that is the first one that is recurring, or the first 2 that is recurring, or the first 3 that are recurring. So whichever method you use, we get the same answer. Okay, I want to differentiate this from this, but this method is only used
But if they ask you to write,
if they
so if they ask you to write it in fraction, will you write it as 999 over 999?
yes,
Or will you just write one?
no, anyone you write will be correct, will be marked for you. Let me be very honest with you. Anyone you write will be marked for you, because it's the same thing. But think of it as just the first digit that is recurring, so that you don't have to go through that trouble. So it just becomes 9 over 9. Just like this one is 4 over 9. Why this one is 78 over 99. This one is 534 over 999. So the number of 9s, that's why I said the number of 9s will be dependent on the number of the recurring digits. If there are 2 recurring digits, you have 2 9s. 3 recurring digits, you have 3 9s. If the first digit that is recurring, you can have 1 9. But like I said, you can think of it as 0.44444444. You know, you can pick. We can think of whether it is first digit that's recurring, or the first 2 digits that's recurring, or the first digit that's recurring. It will still give you the same answer. Okay, I need you to try this. By the way, don't forget this method, this sharp method is only for this typo. I hope you know. You can't use it. You can't use it for this one I explained to you down here. You can't use it for this. This one must be worked out. You don't use it for this type. You must follow this method to get this one down here. So I want you to try this. So can we try this? The repeating decimal, you need to write them in fractions. Okay? Are you ready?
Okay. Should I do it now?
Yes, now please. Fill them up now. Okay. So you got all this, and you say you verified your answers. You verified them by yourself, right? Can you still hear me?
Yes.
All right.
Yes,
Did you really verify this one? What did you do here? Because
yes, I can
it's
hear
also,
you. I verified the answer.
what did you, I hope you know this thing means 0444444. The recording started from 4. Okay, I believe
Which one?
this third one. Let me call this number 1, number 2, number 3, then number 4, 5, 6, 7, 8, 9.
Yeah.
Do you know? I hope you know the recording started from. I'm talking about 3. The recording started from 4. So this is actually 0.04444. Did you observe? Did you take that into consideration? Did you take that into consideration when you were working it out?
Yes, I did.
Okay, you know what you do? Do 4 over 90. Let me see what it gives. What does 4 over 90 give you? Just to confirm. It gives
0.4444.
Alright.
0.44444.
Recording. Okay, this one is 241 over this.
But I also checked.
You also did one? Because I know this one is 3 over 9, which gives you 1 over 3. So that's correct.
Oh, okay.
That's correct. This one is this. This one is this. This one is this. Okay. Is this 13 over 99? This last one.
Yes, 13 over 99.
Alright, very good. Okay, I think that should be it. Alright.
Please don't forget to like, subscribe, and comment. Thank you so much.
Welcome to Like Learning School, your premier online education platform. At Like Learning School, we are dedicated to helping students and learners unlock their full potential, providing them with the foundation, support, and guidance they need for academic excellence. Our platform caters to 2 main target audiences. Firstly, we work with school children of all ages, offering academic follow-up and accountability partnerships. Our seasoned tutors provide personalized attention to ensure students stay on track and reach their goals. Secondly, we support students and learners who are preparing for internal, external, entrance, or professional examinations. We offer comprehensive and well-structured support to help them achieve outstanding performance in their exams. Our robust virtual courses are designed to keep students engaged and motivated. With interactive videos showcasing our teaching sessions, students actively participate in the learning process, making education enjoyable and effective. But that's not all. We believe in personalized education. Our students have access to personalized tutorial sessions, whether online, physical, or hybrid, tailored to their unique learning needs. Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.